So it says solve the following simultaneous linear equations using matrices. So we have to use the matrix method to solve this. So what we will do is we will convert this set of equations into matrices. Notice the numbers are going to stay in the same columns they are in the same rows, and the x is in the column position, but it's going to become a row, and the y is in the column position and becomes a row. So if we were to multiply these two out, we'd end up with the minus 5x plus 4y and the 7x minus 6y, because it's the first, it's row by column, so position 1 by position 1 and position 2 by position 2. So going from here to here is sound. If you need to take the time to multiply this out to see that that's fine. And then we create a column matrix right here. We need the inverse, and the way the inverse is found is we need the determinant. So if we label our matrix A, B, C, D, then it's AD minus BC, and notice that goes in the denominator. So this is the reciprocal of the determinant. We switch the minus 5 with the minus 6, and we make the 7 and 4 diagonal 7 and 4 negative. So the lead diagonal will switch. The following diagonal will become negative. And so when we put these numbers into this equation or this expression, and I'm very much sure, I believe you will have to memorize this. This is probably not going to be given to you. This is for BGCSE students. This is given to them, but college students, no. I don't think that is. I could be wrong. So when we plug these values in here now, this is actually just going to reduce to 1/2. And so a half of these numbers is just going to be minus 3, minus 2, minus 3.5, minus 2.5. So we're multiplying both sides of the equation by the inverse. What's going to happen when we multiply by the inverse, that's going to eliminate everything except you're going to finally end up with x, the column matrix xy. So this portion of the equation is going to become the identity. So when we get here, notice we end up with the identity matrix. If you need to pause and verify the multiplication, that's fine. But remember, it's row by column. So the first position multiplies the first position. And so after going through all of that, you're going to just end up with the column matrix xy. So the left side, once you set up your inverse, you can immediately just assume that this portion here, this inverse, will sort of eliminate this matrix here. When I say eliminate, we're just setting it up so that it's basically the number 1. And so once something is multiplied by 1, you don't have to show the 1. So basically what we want to look at is the right side, which would be the minus 3, minus 2, minus 3.5, minus 2.5, when it multiplies the minus 40, 58 column matrix. That's going to give us so the way it's going to work is it's going to be, so all of this working from here to here is just showing that the inverse matrix is going to multiply this matrix and bring it and eliminate it. So that's pretty much just working more like a proof. You don't need to show this portion on the exam. You can go directly, well, after you show this first step here, you can go directly to this portion here because you want your inverse to multiply this column matrix. And notice I'm putting the column matrix the inverse matrix in the front because if this was a 2 by 1 trying to multiply a 2 by 2, it wouldn't work. So the 2 by 2 has to multiply the 2 by 1. So it does matter where you put it. It has to go in the front. If you try to put it in the back, it is not going to work. So when we multiply, it's going to be row by column. So minus 3 multiplies the minus 40, and minus 2 multiplies the 58. And then the negative 3.5 multiplies the minus 40, and the minus 2.5 multiplies the 58. So it's the first position multiplying the first position, the second position multiplying the second position. And once we do that, we're going to end up, because all of this is just calculator work, you're multiplying and then adding, you're going to get 4 and negative 5. After you get your solution, x is equal to 4 and y is equal to negative 5, you can do a test to check and see if it's the correct answer. This is the original set of equations. If we put the 4 where the x is and the minus 5 where the y is, we're going to get minus 20. Minus 20 is equal to minus 40. That is correct. If we choose the second equation and we substitute, we're going to get 28 plus 30, which is still 58. So the solution set that we have is accurate, and hopefully this helps.